Hello, Mr. Collier here. This is Lab 9.2 and it's about levers. In this lab we're going to be collecting data about the input and output forces required to lift a weight using a lever. We're going to also be able to manipulate where the fulcrum is and see how those forces change. Because it's a lever, we're also going to have input and output arms, and we'll show that as we get this lab going. For this lab you're going to need a fulcrum. We have a little metal thing. We have 2 meter sticks taped together to give us a stiff lever, and we also have holes at either end for us to attach the spring scale. This is a 10 Newton spring scale, and we've got a little bundle of weights held together with a rubber band. The first thing we're going to do is weigh our little pile of weights. This is going to be the output force for all of our trials. These weights have a weight of 5.8 newtons. So on our data table, the output force is always going to be 5.8 newtons because we're always lifting those weights off the ground. In this lab, we're going to do 3 trials manipulating where the fulcrum is. First at 50 centimeters, then at 40 centimeters so that the input is slightly longer than the output, and finally at 60 centimeters so the input is shorter than the output. For each trial, I'm going to measure the amount of force it takes to lift the output. One thing you want to remember to do is re-zero the spring scale while it's upside down. Here's our first trial. We have the fulcrum at 50 centimeters and the output at the other end. I'm just going to pull down until my weight balances and I get a reading of 6 newtons. Now with the fulcrum in the middle, the mechanical advantage should be exactly 1. But because of loss of energy, a little bit of bending in the meter sticks, we're going to end up with a slightly smaller mechanical advantage. For the second trial, I'm sliding the fulcrum over so that the input arm is 60 centimeters and the output arm is 40 centimeters. I'm pulling until it balances. This one takes less effort. We are at 3.4 newtons. And for the last trial, we're going to slide the fulcrum so that the input arm is short, 40 centimeters, and the output arm is now long, 60 centimeters. Now the amount of input force it requires to lift the weights is about 9.2 newtons. So here's the data we collected. For your calculations, it's very simple. We're going to calculate the mechanical advantage 2 different ways. First, by taking the output force and dividing it by the input force to get the mechanical advantage. Then by dividing the input distance divided by the output distance to get mechanical advantage. Theoretically, the 2 mechanical advantages should be identical, but in actuality, I think you'll find them a little bit different because the theoretical does not take into account things like friction or the lever bending. So you'll have slightly different mechanical advantages on this side. And that's it for Lab 9.2, levers.